Okay, so let's look at assignment number 2. Assignment number 2 is going to be found at the end of chapter 4 in your book, and it starts on page 101. So you'll notice here that our first set here is for 5, 6, 7, and 8. So let's take a look at those. Okay. So for number 5 here, so 4-5, and this is on page 101. Okay. It's in the second column. It says graphically position the links of the compressor linkage in the configuration shown right here. Okay, so notice that you're given lengths. So 100 millimeters for the length of that connecting rod. We have 45 millimeters for our crank. It's rotating around this point right here. And where it's at right now in space is 30 degrees. Okay, and then we have our piston out here, which would be a slider. Okay, so you're going to first draw that kinematic diagram in the position that you see here. Okay, then what you're going to do is from this position, you're going to reposition the links as that 45 millimeter crank rotates 90 degrees from where it's at. So don't position this straight up and down. So you're going to go 30 plus 90. So it's going to be like over here, okay, is where the new crank is going to be. Does that make sense? Okay. And then you want to determine what the resulting displacement of that piston is. So if this is where it's at originally, right, in the 30 degree position, then when I rotate this back, it should move this way, right, into a new position. And all you want to know is what is that difference? What's that delta? Okay. And that's going to be 4.5. Okay. Using that very same diagram for 4-6 here now, what you're going to do, and it's going to start with the original 30 degrees. So for 4-6, you're starting with the original 30 degrees. And then this time you're going to move that crank 120 clockwise. So now you're going to go in the opposite direction from the 30 degrees. So you're going to go 30 plus 90. So you're going to actually be down here and you're going to go in this direction. And you're going to find out which way and what happens from this position. You know, what happens now? Where is that piston in relationship? Okay. So that's number 6. So these two use the very same diagram. So you kind of like draw one diagram if you would, and then like copy and paste it for both. Okay. Then we're going to turn the corner. We've seen this one before. This is 4-7. And 4-7 and 4-8 go together. You are going to use this illustration. Okay. And it says graphically position the links on the shearing mechanism in the configuration shown. So right where it's at right now in space. Okay, right there. And then from that, you're going to reposition the links as the 3/4 inch crank is rotated 100 degrees clockwise. So you're going from here and you're going to be going clockwise. You're going to go this way, right? This way. And you're going to go 100 degrees from where it's at right now. Determine the resulting displacement of that blade. Okay, so this is its original position, if you would. This is like 0 degrees, right? So where is it from there? Okay. Then what you're going to do is you're going to go to number 8 and you're going to say, okay, from that original position, now you're going to reposition this so that the blade is lowered 0.2 inches. Oh, wait a second. Determine the resulting angular displacement on the crank. So this time you're going from, okay, if I'm starting here and I want to position this down 0.2 inches, I'm going to pull this down. Oh, what happens over here? So it's kind of like an opposite problem. So we're actually doing the output and we want to find out, okay, where's the input, the crank then at that position? Okay, so just manipulating it a little bit differently. Questions on that? All right. Now we're going to go to number 13 and number 14. This is the third illustration. So again, here we've got a rock crushing mechanism. It's in right here, graphically position the links exactly the way you see it right now. And then you're going to reposition so that that crank right here is going to rotate 30 degrees clockwise. So from where it's at right now, we're going to go 30 degrees clockwise and we're going to see what happens over here. Okay, determine the angular displacement. So not linear here. You want to do what is the angle from where this was originally to now the new angle. It's an angular displacement. So make sure that you show it as an angle. And then number 14, starting with the same position, now you're going to reposition so that you go 150 counterclockwise. So from where it's at right here, you're going to go 150 counterclockwise in this direction. And again, angular displacement, not linear. Okay. Now, those are the only three, if you would, diagrams that you're creating. You're creating one for the rock crusher, one for the shearing mechanism, and one for this piston arrangement. Okay. So you've got an inline slider. You've got an offset slider. Sliders over here, and you've got the offset there. And then you've got like a crank rocker. Okay. Now, I'm going to go forward. On page 106, you're now going to go back to the inline piston arrangement from problem 5. And you're now going to find the limiting position. What is its furthest point out and what's its closest point out? And then you are going to determine its maximum linear displacement or the stroke of that piston. Okay. So going back to 4-5, the first problem, you already have this drawn up. All right. You have it drawn up the first time already. Now you're going to position it so we're all the way laying down and we're all the way out. And then you're going to position it where it's overlapping and we're all the way back. And you're going to measure the distance between those two and you're going to find out what the stroke is. Okay. Then for number 57, you're going to do that very same thing for the offset slider. That is that shearing mechanism. You want to find out what's the stroke of that. We're going to put it in its limiting positions. We're going to push this. We're going to push this so it's inline, 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 and then our blade is all the way down. And then we're going to do the overlap and it's going to be all the way up. And what's that difference between those two? Okay. And then lastly, you're going to do that very same thing for problem number 58. You're going to go to your rock crusher and you are going to find what is the furthest out that this is going to oscillate and what is the closest it's going to oscillate. And this time it's not a linear displacement. It's not a stroke. It's going to be the throw, the total angle that it goes back and forth within. Okay. All right. So we get a lot of mileage out of each one of these, if you would. Okay. All right. So then when we have those done, then you've got 2 more problems to do. And the last 2 are going to be displacement diagrams. Okay. And the first one is going back to the first piston problem, the inline piston problem. And what you're going to do is you're going to create a displacement diagram. Now, you can use the Excel spreadsheet that I have out there that we just looked at. Okay. But the deal is when we go back to our assignment, you can use that spreadsheet to prove your displacements and the stroke. But then what you want to do is I want you to draw out the 30, 60, 90, 120, 150, every 30 degrees up to 180 degrees. And what I'm asking for is, if I go back to the module, I'm asking for it repositioned similar to this. Okay. Where you can see those angles for that. All right. And then for 71, this one is going to be the offset. You want to do a displacement diagram for that one. Now that one, I don't have, I didn't have you guys do the, Excel spreadsheet, but if you have in another course, because some of you had a different instructor, that's okay. You can use that. But for this one, you can do it completely graphically. What do I have? Oops, no, I clicked the wrong thing. I gotta go back to the assignment. For this one, I want you to do the diagram every 30 degrees to get that full cycle all the way through. Okay. And then you want to show your work, you know, every 30 degrees, plotting the displacement on a displacement diagram. And then no spreadsheet is necessary unless you have one already done. You can use that to check your work as well. Okay. All right. And these two, so for instance, there's technically, if you would, I know there's more work than this, but technically there's 3 diagrams. And then there's, 2 displacement diagrams that you're going to do. And then you just kind of manipulate those 3 around according to the directions. Okay. So a little bit of CAD work, all right, here. But what's nice is because it's CAD, there is some cutting and pasting that you can do from problem to problem, which is nice. You don't have to redraw. Okay. So any questions at all on the second part here and the assignment that we have? Okay, all graphical solutions. If you didn't want to use the spreadsheet, you don't have to, but then you just have to do the every 30 degrees up to 180 degrees for that displacement diagram, okay? You still have to plot the displacement diagram, but you would have to do it manually. So if you look here in the book, you could create this in AutoCAD if you wanted to. You don't have to use Excel if you don't want to. And you can just to scale, draw that up if you wanted, and then do a best fit curve through the points that would correspond. Okay. Or you can use Excel because many of you are, very familiar with Excel, especially if you've had the computer programming class. But if you're like, I'd like to take a break or I'd like to do it manually, you can do that too. Okay. Either way. So any questions? All right. So that's all that I have for this second part. So that kind of completes our module 1, if you would. Okay. So between now and the due date for this, which I believe is about a week from today, then you have time to work on it, ask me questions as we get together, or if you want to continue to work today independently, that's totally up to you. Okay. So I'll be here to answer any questions that you have as long as you want to stick around for our time together. So I'm going to stop recording.